In 2.3, we're going to look at acceleration. And acceleration is taking that velocity that we've looked at in the last section and changing it in some way, either changing the magnitude or the amount or changing the direction. This is a video by Khan Academy about acceleration, and I will link that in our information, but it's a good one to kind of give you an introduction to acceleration and how to solve some of those problems. So we'll look at that at another time. First of all, average acceleration is looking at a change in your velocity over a certain time period. So when we look at the equations to solve for acceleration, we're going to have change in velocity over change in time. And typically that change in time would be like saying, if I started at a time period of 0 and I traveled for 5 minutes, my change in time would be a total of 5 minutes. So I would have for change in velocity to be final velocity minus initial velocity. Or I could say VF, final velocity, equals initial velocity plus AT. This is a vector quantity, so it will account for the direction, and the units are going to be meters per second squared. So you'll have to make sure that you have that squared over your meters as well. Deceleration is not a term in physics. Deceleration would be considered a negative acceleration. So you would be going the opposite direction, or you would be making your acceleration negative or slowing that object down. So when we look at average acceleration, we can solve this a couple different ways. So when we do average of anything, we add up each component and divide by the number of parts that we have. So if we have an initial velocity and a final velocity, we've got 2 velocities, so we would divide that by 2. So we can say average is equal to 1/2 times initial velocity plus final velocity. Or if we were to manipulate those variables and move them around, we know that x, or distance, is velocity equals distance over time, or we can get that distance by multiplying velocity times time. Or we can say that 1/2 VI plus VF equals or times t. Any of these equations that you see like this, I would put down on your equation sheet. So these are the equations you will need for acceleration, and it's going to be very important that you have these somewhere that you can use them. So let's walk through them. So first, we have final velocity equals initial velocity plus acceleration multiplied by time. Then we have our distance or displacement equals 1/2 multiplied by VI plus VF times t. Distance equals VI times t plus 1/2 times A times t squared, and it's just the t that gets squared there. Then this last one, we have final velocity squared equals initial velocity squared plus 2 times acceleration times the distance. And again, these are going to be very important. You will be able to use these on quiz. As we look at some of these sample problems, make sure you keep referring back to these equations. So for the first one, we have a jet is taking off the deck of an aircraft carrier. Starting from rest, the jet is catapulted with a constant acceleration of 31 meters per second squared along a straight line and reaches a velocity of 62 meters per second. Find the displacement. So on any of these problems, the first thing that we want to do is write down everything that we know. So we'll just make a list of all of our variables. So it says it's taking off starting from rest. Anytime we see that, that means the VI is 0. So we can write that down. It's catapulted with an acceleration. So A is 31 meters per second squared. straight line reaching a velocity of 62 meters per second. So then if it reaches that velocity, that's our final velocity, 62 meters per second. And we want to find the displacement. So we're looking for D. So then on all of these velocity problems, there are 5 variables. Problems are going to give you 4 that you have to work with. So when you look at these equations, you need to look at, what do I have? I've got everything except T. So I want to find the equation that doesn't have T. And in this case, it's this last one, the VF squared equals VI squared plus 2AD. So we'll come back and we'll use that. So VF squared equals VI squared plus 2AD. So now it's a matter of plugging in our variables and solving. So we've got 62 squared equals 0 squared plus 2 times 31 times D, which is what we're looking for. So when we solve this equation, D ends up being 62, and making sure that all of our units are constant. So we've got meters and we've got second. So meters will be our unit for the displacement here. On this next problem, it says a spacecraft is traveling with a velocity of 3,250 meters per second. So that's our VI. 3,250 meters per second. Suddenly, a retro rocket is fired. The spacecraft begins to slow down with an acceleration of 10 meters per second. So acceleration, it says, is 10 meters per second squared, but it says it's slowing down, so we need to make that negative 10. So always pay attention to that. What is the velocity of the spacecraft when the displacement of the craft is 215 kilometers? So we're looking for final velocity. And it says the displacement is 215 kilometers relative to the point where the rockets begin to fire. Okay, so we have velocity, acceleration, and displacement. Again, we don't have time, so we're also going to use that same equation from last time. Before we start checking our units, we've got meters per second squared, and kilometers. So we need to change this to meters. So 215,000 meters to make sure everything's in the same unit. So we're going to use VF squared equals VI squared plus 2AD. And now it's just a matter of plugging in the equations and solving. So if we plug that in, we've got VF is what we're looking for. VI we said was 3,250, so squared, plus 2. A is negative 10, and our distance is that 215,000 meters. So when we solve, make sure that you square root your answer. VF ends up being 2,502.5 meters per second. And if we look at this, we started out going 3,250 and we were slowing down. So that makes sense as our answer. In this next problem, we have a motorcycle rides consistent of 2 segments. During the first segment, the motorcycle starts from rest, has an acceleration of 2.6 and a displacement of 120. Immediately after the first segment, the motorcycle enters the second segment and begins to slow down with an acceleration of negative 1.5 meters per second squared until its velocity is 12 meters per second. What's the displacement of the motorcycle during the second segment? So we need to look at what's going on here. So first of all, the motorcycle is starting off, and then it's going to speed up its velocity to a certain point. So this would be like segment 1 and segment 2. Once it gets to this midpoint, then it slows down till it gets to a certain point. So whatever this velocity is here at this point, the final velocity of segment 1, that'll be our initial velocity that we'll use in segment 2. So let's make a list again. Starting from rest, so VI equals 0 in the first segment, has an acceleration of 2.6 meters per second squared and a displacement of 120 meters. That's for the first segment. So I'm just going to stop there, and we're going to solve for the final velocity of this first segment. So we've got VF is what we're looking for. So we got VF, dA, VI. So we're going to use VF squared equals VI squared plus 2AD. So VI is 0 plus 2A we said is 2.6, and D is 120 meters. So we end up getting VF on this part, as my calculator says 24.98, so I'm going to say 25 meters per second. So VF is 25 meters per second. Now, I'm going to erase this, give us a little bit more room, maybe. Okay, got it. Now, so for the second segment, the VF here is our VI, so that will be the 25 meters per second. We can continue on. It says during that second segment, it begins to slow down with an acceleration of the negative 1.5. So our acceleration now is negative 1.5 meters per second squared until its velocity is 12 meters per second. So now the VF is 12 meters per second, and we're looking for the displacement. So again, we'll take that VF squared equals VI squared plus 2AD. So VF this time is 12, so that's squared, equals VI is 25 squared plus 2A was negative 1.5, and here we're looking for the D. So when we solve this out, D ends up being 160.3 meters.